This is Team Witty Cleeks, and we present to you our idea, BlockIntel. This is an evidence management system which leverages the concept of blockchain to provide integrity and provide security to the evidences which are collected. The main major issue while handling evidences is that the data can be updated and the data can be tampered. So, using blockchain, we create databases where the evidences are submitted and the data is tamper proof. Not only this, we have created various tools which can help in forensic investigation related to these evidences. And also, we can automatically generate reports for these data because when we are handling evidences, they can be of various sizes and various formats. So, for handling various formats and going through all hundreds of GBs of data, we have created reports which automate these processes. So we will go through all these tools and all these reports one by one. First of all, we will go to the tools section. These are a set of tools we created for the simple task of bit by bit image creation. There are various pen drives, storage devices which we want to clone it, and we want to then store it to our digital evidences. So if we have a pen drive, if we have a CD, or we have a folder, we can just create a bit by bit image using which the image is created, and it will not use the deleted files as well. So it will have all the data which we can later on use for forensic investigation. We will have a demo of these tools at the end. Then we will go to the dashboard. This is the main page where we upload various evidences. So we will just fill these. The first would be uploading a folder. We will just select this test, then the project name, which project is this under, then a simple description. What this process does is we upload these files to an IPFS using Pinata, and after this is uploaded to IPFS, this make sure we have a database which is distributed, and we generate an CID. Then CID is just used to create the blocks so that the data is tamper proof. So this is uploading. Okay, so we have generated the IPF hash. We can also view the websites. For example, first is the Ganache, where we have locally stored all the like blockchain using Ethereum and smart contracts. Then we can also use the Pinata. We can also show that Pinata, and you can see test.zip. We have uploaded all this data, and using Pinata and Ganesh is for the local development, and it ensures that the data which we have uploaded is tamper proof, and in future also it will be very proof. Next is we have the option to download the data. This is a button we can use to click and download the data to create a sample to do the reports. Then the next section is the report section. When we click on report, this data is sent to our backend, which is the AWS server, which works on various processes. For example, the Yara rules, exif tools, scans for embedded files, file detection. After doing all these processes and checks, it lists down all the potential files which may have hidden evidences or anything which is related, which can help in the progressment of this case. So as you can see, these are list of the PNG images. Even if you have changed the file name, we can also detect that the file name is changed. If we have embedded files which are zipped behind all these data, we can also extract these. And these are all the list reports we are generating. So what this does is it reduces the time of going through evidences, because if we have a device and a large storage, we cannot manually go through all these files and check for all these suspicious files and perform manual checks. That's why we have automated this process using all these different tools in the backend. So this is the front end. The next would be a demo related to our tools. We will be looking at the different tools which are present. So this is the bit by bit imaging creating tool, which can be used for cloning an image for this a normal file structure also, and this will create a bit by bit image, and then later on we can use that image. And apart from that, also clone an entire drive. For example, in this example we have two drives, and then we can select which drive we want to clone, and then this will start the execution of creating a image of the drive, which later we can use to store it and analyze.